Bismillahirrahmanirrahim. Hari ini kita akan sambung lagi kita punya topik untuk chapter 2. Still lagi under chapter 2. Chapter 2. Still lagi on UV part. Ya, UV. Okay, IR belum lagi. UV kita dah tengok compound. What are the types of compound, or what are characteristic of the compound that can absorb UV. Then now we will look at the application. Okay, application of UV. Okay. UV can be used to do qualitative and also quantitative. Okay. Based on our past experiment, UV for qualitative is when we scan absorbance versus wavelength. So we will get this kind of graph, okay, spectrum, ya. Yeah? Okay, kalau concentration dia lebih tinggi, dia akan bentuknya sama, cuma ketinggian dia berbeza. For quantitative, normally we will plot a graph of absorbance versus concentration. Okay. For example, the one that we did in our UV experiment is analyzing potassium permanganate. Okay, each compound has its own lambda max. Okay, tak berapa nak lurus saya lukis. Okay, this is called lambda max, which the absorbance is the highest. Yeah, that is called lambda max. And when we convert into quantitative analysis, we fix the wavelength at the lambda max, and the result will obtain like this. Okay, because now we change the concentration. While doing the qualitative, it doesn't change the concentration. We just scan by changing the wavelength, so we get a spectrum. Okay, but for this we get the absorbance at each peak. Okay, for example, this one represent this. Okay, this is number 2 represent this. Okay, kalau ada lagi the highest concentration, the shape will be the same, cuma dia punya absorbance will be higher. Okay, so from that we can plot a calibration curve, and if we have an unknown, we get the absorbance for the unknown, and by extrapolating the graph, the calibration curve, we can find the concentration of unknown. Okay, so that is the difference between qualitative and quantitative. Okay. So for quantitative, yeah, this is quantitative analysis using UV. It use a Beer's law or Beer's-Lambert law as a base of a concentration calculation. Okay, so what is Beer's law? Beer's law is equal to A is equal to epsilon BC. Okay, so by using this graph, this equation, and plotting the graph using the instrument to get the standard reading, yeah, standard absorbance, we can do 2 methods of quantitative analysis. The first one is calibration curve methods, and the second one is standard addition methods. Okay, so okay, it's okay. in the next slide, in the later slide, we will see the difference between these two. Okay, between calibration curve method and also standard addition method. Okay. So how do the instrument measure the absorbance? We must always work at the wavelength of maximum. Okay, lambda max lah tadi ni ya. Okay, because this is the point where it has the maximum response due to better sensitivity and lower detection limit. We also have we also can reduce error, okay, in our measurement when we perform the analysis at lambda max. The reason why we need to perform analysis at lambda max is this one, maximum response, because better sensitivity and lower detection limit. And the second one is we can reduce error. Okay, so that is two reasons why normally we perform the analysis for quantitative at lambda max. This diagram show the significance of lambda max. That's why we need to read the absorbance at the lambda max, because I try to explain this. If we have a small variation of wavelength during our measurement, there can be a large difference in response if we are not performing analysis at the lambda max. Okay, if you look at this one, this is at lambda max. Okay, even though you just deviate a little bit while performing the analysis at lambda max, your absorbance will not change much. Okay, your absorbance will not change much. But if you are not perform at the lambda max, different concentration will give a slightly bigger difference. Okay, lain kan? So ini besar sangat dia punya difference dia daripada the original value. Okay, so kalau kita perform not at the lambda max, kita punya error lebih besar lah. Macam itulah saya boleh cerita. Okay, okay. So for quantitative, we have quantitative methods. We have two ways of performing quantitative methods ni. First, calibration methods, and the second one is standard addition methods. Okay, for this you need to know why some sample suitable to use calibration method and why some sample suitable to use standard addition methods. Okay, and the second is how or what is the difference between calibration method and standard addition method. How the procedure, kalau saya boleh kata procedure lah kan, tapi sebenarnya it is not called procedure. What is the step or what is the principle for calibration method dengan standard addition methods? Okay, first we look at the calibration curve methods. Okay, calibration curve method is a general method to determine the concentration of a substance in an unknown sample by comparing the unknown to a set of a standard solution of known concentration. Okay, this is the one that we are performed during our UV experiment. Okay, we determine the concentration of unknown substance by comparing the unknown to calibration curve of a standard. Kan, you are prepare standard 10, 15, 10, 15, 20 kan, ataupun 5, 10, 15 kan. Okay, so ambil satu unknown tu instrument akan bagi absorbance. Okay, so katakanlah kalau absorbance dekat sini, so you tahulah what is the concentration here. Okay, absorbance, it is still the same lah. Sorry, saya tak lukis. It is a graph of absorbance versus concentration. Okay, so once you have run the standard solution, you will get this kind of graph. Okay, this kind of graph, and from this graph, when we measure the unknown, okay, it will give you the absorbance value, and you extrapolate it at the graph, you can find what is the unknown solution concentration. Okay, so that is calibration method. Wait, I want to find the standard addition method explanation. Okay, sorry, there is no standard addition method. Okay, tak ada ya. Tak apa, maybe later on the next slide. So this is a step how to measure the concentration of unknown. So first, practically you have measured the absorbance of your unknown. Once you know the absorbance value, you can just read the corresponding concentration from the graph. Oh, sorry. No, sorry. Saya rasa ada step yang tertinggal. First, we need to read an absorbance of known concentration. Okay, untuk dapatkan plot ni kan. Okay, okay, tak nak lah. Saya tak nak baca yang ni lah. Saya nak tengok yang ini. Okay, first, prepare a series of standard solution with known concentration. This one yang kita dah buat dah. Kita buat 3 je kan. 5, 10, 15. Okay, tapi sebenarnya yang minimum sepatutnya 4. Yang paling cantik 5 lah. Okay, tapi hari tu mungkin kekurangan volumetric flash, we just do 3 reading of a standard. Then we measure the absorbance of the standard solution. Once we get the absorbance value, we plot a graph of absorbance versus concentration. Okay, absorbance versus concentration. ppm is also concentration unit. Find the best straight line by using least square method. Okay, this one untuk statistical process lah ya. Nak dapatkan least square method. Least square method ni nak dapatkan garis yang paling bagus dia punya R square value dia. Tapi kita tak buatlah benda tu kan, sebab komputer dah tolong buatkan untuk kita ya. Instrumen dah tolong buatkan untuk kita. Okay. Okay. Okay, ya. So itu sahaja untuk quantitative methods. Cuma sekejap saya nak tengok yang ini ya. Okay, once we get a straight line, this is actually, oh goodness, macam ada tertinggal lah. Tapi tak apa. Kalau tak ada dalam ni, tak perlu ni. Kalau keluar, tak apalah nanti ni. Okay, from the graph, the slope of the line, yeah, m is equal to x, xy, s, xx, and the intercept value b, intercept is b. So the equation for the least square line is equal to this one, yeah. Y is equal to mx plus c. Okay. Okey, cukuplah sampai sini je untuk calibration, untuk application of the UV. Okey. Saya rasa saya stop dulu sampai kat sini. Saya akan sambung infrared absorption spectroscopy on the next video. Okey. Assalamualaikum.